Hello everyone, welcome to POESI's e-learning and certification services. This is a new video session in the MQTT series. And in this session, you will learn about a special feature of MQTT protocol, QoS, Quality of Service Agreements. As we know, communication is all about having common mutual agreements. It is essential for systems engaging in communication to adhere to a set of rules. Mutually agreed upon set of rules is called a protocol. A protocol followed by applications to create and interpret messages is called application layer protocol. MQTT is an application layer protocol that defines three levels of quality of service agreements. QoS 0 means message delivery happens once or not at all. QoS 1 message delivery happens at least once. QoS 2 message delivery happens exactly once. These agreements are made between a pair of sender and receiver application. A publisher and broker makes a pair. Similarly, a broker and subscriber makes another pair. Each pair is treated independently, means a pair's QoS agreement doesn't depend on another pair's QoS agreement. However, the end-to-end QoS depends on individual pair QoS agreements. The end-to-end QoS is always the lowest of pairs QoS levels. For example, a message published with QoS 0 on broker will result into end-to-end QoS level 0 irrespective of the broker subscriber pair QoS. Let's consider another case. A publisher broker QoS level 2 and broker subscriber QoS level 0 combination offer end-to-end QoS level equivalent to QoS 0. One more thing, a client object created in an application can use different QoS for publish and subscribe. Let's dive deeper to know more about different QoS level agreements. Quality of service level 0 or QoS 0, also known as fire and forget model of message delivery, because in QoS 0, a sender sends message and disconnects itself. No response is sent by the receiver and no retry is performed by the sender. The message arrives at the receiver either once or not at all. Message delivery guarantee entirely depend on the underlying transport layer protocol, TCP. It is preferred for non-critical operations where loss of message could be affordable. Quality of service level 1, QoS 1, guarantees message delivery at least once. However, there could also be multiple delivery of the same message. Let's see how does it work. The sender sends a message, stores it in a queue, and waits for an acknowledgement from the receiver. On receiving the acknowledgement, the sender deletes the message from the outbound queue. If the acknowledgement is not received in a predefined time, sender resends the message with a duplicate flag set to 1. This repeats until the sender receives the acknowledgement. Duplicate flag is not processed by the receiver to treat, discard duplicate messages. There is always a possibility of delivery of multiple copies of the same message. Seems simple, right? No, it is not. There are a couple of implications. Let's consider two different cases to find out. Case 1 is a normal message delivery. The broker publishes a message on the subscriber and stores a copy of the message in the outbound queue. Subscriber is a light bulb. After receiving the message, subscriber sends acknowledgement to the broker. Broker receives acknowledgement and deletes message from the outbound queue. All went well. But now let's consider a special case. The broker sends a message, keeps a copy of the message in the outbound queue. Subscriber is same light bulb. After receiving the message, it sends acknowledgement to the broker. But because of some network issue, acknowledgement is lost on its way. When broker doesn't receive acknowledgement, it waits for a predefined time period. Default is 5 seconds. And after that, it retransmits the message. So the second copy is delivered to the subscriber. Subscriber again sends acknowledgement, but because of the same network issue or because of some other issues, message is lost. When broker doesn't receive acknowledgement, it retransmits the message, and this keeps on going. Let's assume that in the 10th round, acknowledgement sent by the subscriber received by broker, and then broker stops retransmission of the messages. But by then, 10 copies of same message would be delivered to the light bulb, our subscriber. Now question is this okay? And answer is yes, because a message on delivered to a light bulb once or 10 times doesn't make any difference. Let's consider another case. In this case, subscriber is an industrial robot and it's waiting for a message to be delivered to it. Move forward. Now, what if this message is delivered to robot 10 times? Can we afford this? Obviously not, because multiple delivery of this command will make robot move in forward direction more than required, and this may even lead to a physical hazard or accident. So in critical cases, QoS 1, quality of service level 1, is not recommended or may not be a good choice. So is there any other option? And answer is yes. Quality of service level agreement 2, QoS 2, that guarantees delivery of a message exactly once. So QoS 2 is what we need in this special scenario. Let us find out more about it. QoS 2 guarantees one-time delivery of the message. There is no possibility of duplicate deliveries. It involves four-way messaging that makes it a bit complex. Let's see how does it work. Let us look at the message flow in case of QoS 2. Here, broker and subscriber is making a pair. We are going to refer to the broker as sender and subscriber is receiver. So the sender sends a message and stores a copy of it in the outbound queue. Receiver, after receiving the message, sends an acknowledgement in the form of pub REC, publish received message. Once sender receives pub REC message, it sends a message pub REL, publish release, to the receiver. After receiving publish release message, receiver sends a message publish complete. After receiving publish complete message from the receiver, sender deletes the message from the outbound queue and the round trip has completed successfully. Now let's look at what can go wrong. So in the second scenario, sender sends a message, stores a message in the outbound queue. Receiver receives the message. It sends acknowledgement in the form of pub REC. But because of some network issues, pub REC is lost on its way. In this case, sender retransmits the message, but with duplicate flag set to 1 and using same packet identifier. Packet identifier is used by receiver to identify duplicate messages and then later on discard them. So this keeps on going as long as sender doesn't receive pub REC from the receiver. Once pub REC is received, sender sends pub release. Now in this case, if pub release is lost on its way, then the receiver once again sends pub REC and it keeps on sending pub REC as long as sender doesn't receive it. Once pub REL has been received by the receiver, then it sends a publish complete pubcom message. Now, in case if pubcom message is lost, sender keep on sending pub release message to the receiver. After the successful receiving of publish complete message, sender deletes the message from the outbound queue. So this completes the round trip. Now it comes to handling multiple copies of the messages. So in this case, the receiver process identifies duplicate messages with the help of packet identifier and it discards all the duplicate messages and processes just one copy of the message. So although this seems complex, but it guarantees exactly one's delivery of the message. So QoS2 is the safest option, but because of the additional overhead, MQTT protocol loses its charm of being lightweight and simplest. This is why QoS2 is only used in special cases. So finally, how to choose the right QoS? And the answer is always consider end-to-end QoS requirement and then choose QoS for the pair. I have 3 examples here on my screen, 3 different implementations. In case of non-critical cases, we prefer QoS0 because of its simplicity and better performance. Example of implementation is sending weather updates to a subscriber just for information purpose. In case of critical cases where message delivery guarantee is required and multiple deliveries are affordable or managed by receiving application, we can go for QoS 1. Example of implementation is a smart door lock controlled by remote mobile phone user. In case of highly critical or mission critical cases where message delivery guarantee is required and multiple deliveries are intolerable, the best option is go for QoS 2. Example of implementation is robotic surgery, where a robot is performing surgery and is controlled from a remote location. So that is all about QoS. I hope you found this session useful. We'll keep learning MQTT protocol. So stay tuned, stay in touch, happy learning.